For decades, this black hole slept in silence. No light, no movement, no signs of feeding, just a frozen shadow buried in the darkness, a cosmic corpse drifting quietly at the edge of a distant galaxy. And then, something happened. Without warning, the black hole woke up. A brilliant flash of X-rays erupted from the darkness, followed by a pulse of radiation so powerful it traveled across millions of light years before reaching our telescopes. Astronomers had never seen anything like it. Black holes don't just turn on. Not after decades of silence, not at this speed, not with this intensity. It was as if a cosmic monster, long presumed dead, suddenly opened its eyes and looked back at us. Today, we unravel one of the strangest events in modern astrophysics, the awakening of a dormant black hole, an impossible ignition that challenges everything we know about the life and death of these cosmic giants. Welcome to Cosmic Vault. A black hole at its core is simple. It consumes matter, or it does nothing. When there is no nearby gas, dust, or stars to feed on, a black hole becomes effectively invisible, silent, dormant. A sleeping black hole emits no visible light, no X-rays, no jets, no radiation from accretion. It becomes a ghost, a gravitational footprint without a physical signature. Many of the black holes in our universe exist in this state. They are quiet because there is nothing left to consume. But astronomers tracked this particular black hole for 26 years. 2 full decades without a single flare, burst, or flicker. It behaved exactly like a dead star corpse should behave. And then, in a single night, everything changed. In late 2024, a routine X-ray survey detected something extraordinary, a sudden spike in energy coming from a region that had been silent since the early 1990s. At first, researchers thought it was an error, a glitch, a cosmic ray strike on the detector. Anything but real activity from a dead black hole. But the signal persisted. It grew brighter, then brighter still. Within hours, telescopes across the world swung toward the source. What they captured left scientists speechless. A black hole, dormant for decades, was suddenly feeding again. Gas heated to millions of degrees spiraled into the event horizon, producing a brilliant flare of X-rays visible across the cosmos. This wasn't a slow reactivation. It wasn't a steady warming. It wasn't a gradual accretion process. It was an eruption, a violent awakening, as if something massive had fallen into the black hole all at once.
Look at the X-ray flux.
But
it's
what?
breaking containment.
I see it. Divert auxiliary power to the dampeners now.
To understand the magnitude of this event, we need to understand how black holes feed. A black hole doesn't suck in the vacuum cleaner sense. It waits, patiently. Gas and dust get trapped in orbit around the black hole, forming a swirling disk, a cosmic whirlpool called an accretion disk. As material spirals inward, it heats up to unbelievable temperatures, producing bright X-ray bursts. But here's the key. Accretion doesn't start suddenly. It builds gradually. Clouds move slowly. Matter spirals inward over years. So how did a black hole go from dead silent to full eruption in what appears to be hours? The only explanation is that something massive, something dense, fell into it very quickly. A gas cloud? A rogue planet? A wandering star fragment? A collapsing magnetic filament? Each possibility raises new questions, and none fit perfectly. One explanation is a tidal disruption event, or TDE. This occurs when a star wanders too close to a black hole. The black hole's gravity stretches the star, pulling it apart in a violent process known as spaghettification. Half the star's mass is flung into space. The rest spirals into the black hole, causing a sudden, brilliant flare. At first glance, this fits the data. A star fragment could reawaken a dormant black hole instantly. But in this case, something didn't match. TDES release enormous light curves that evolve over months. They have a distinct signature, a thermal glow that slowly decays. This event lacked those characteristics. The flare appeared different, sharper, more focused, more like a sudden ignition than a long burn. It's as if the black hole didn't tear apart a star, but swallowed something much smaller yet far more compact. Some astrophysicists suggest a magnetic reconnection burst. Black holes build up magnetic fields around their accretion disks. When these fields twist too tightly, they can snap, releasing enormous energy in a sudden flare. Think of it like a cosmic rubber band breaking. Such an event could explain the speed of the awakening. But this raises a major problem. A dormant black hole has no accretion disk, no material, no magnetic structure to snap. For a magnetic burst to happen, there must first be matter accumulating. But the telescope saw no buildup in the weeks or months before the flare. This black hole went from zero to eruption with no warning. Something is missing from our model. The most intriguing possibility is also the simplest. An unseen object fell into the black hole. A compact object like a brown dwarf, a planet-sized rocky body, a dense asteroid cluster, a primordial gas lump, a solitary rogue star core. If something heavy, dense, and fast entered the black hole's region, its sudden infall would produce instant heating, instant X-ray flare, instant accretion ignition. But this theory also carries a profound implication. For 26 years, this black hole had nothing near it. For something large to suddenly appear, it must have come from far away, or have been orbiting invisibly for decades before shifting trajectory. Both scenarios reveal an unsettling truth. We do not understand the full dynamics of the environment surrounding dormant black holes. There may be objects drifting through the cosmos that our instruments simply cannot detect until they are consumed. What truly unsettled scientists was not the flare itself, but the pattern that followed. After the initial eruption, the black hole produced small rhythmic pulses of X-rays, not unlike a heartbeat echoing from the darkness. This was unexpected. Accretion events usually decay smoothly. They do not create repeated pulses. These pulses suggest the black hole is continuing to feed, or it is interacting with the remains of the infalling object, or the magnetic geometry is settling, or something else. Something new is occurring. For the first time in decades, scientists had the chance to study a black hole in the very moment of reawakening. And what they observed did not match any known behavior in theoretical models. This event forced astrophysicists to confront a profound and humbling idea. We have assumed black holes are predictable, but they may be far more dynamic, reactive, and volatile than we ever imagined.
Signature on screen 3.
This confirms the hypothesis.
This black hole's awakening is not just a scientific curiosity. It is a reminder of how little we truly understand about the universe we live in. Black holes do not age like stars. They do not obey simple life cycles. They do not follow rules we can easily summarize in textbooks. They are unpredictable. They are ancient. They are capable of sudden, violent behavior even after centuries of silence. And in a galaxy filled with hundreds of millions of black holes, how many others are sleeping right now? How many might wake up tomorrow? How many eruptions, flares, and shifts are happening across the universe this very moment, beyond the reach of our telescopes? This awakening is more than a cosmic event. It is a message, one written not in words, but in light and energy. The universe is not still. The darkness is not dead. Even the quietest monsters can rise again.